All right, so far we've spoken about quite a few trig identities that are going to be helpful with solving equations and also just proving that other identities are also identities. But we do have some more to add, and it comes straight from the definition of sine, cos, and tan. So let's get right to it. So here to the left we have three graphs: y equals sine x, y equals cosine x, and y equals tan x. And I also have my unit circle over to the right so that we could kind of compare the unit circle with the graphs. Now let's start just looking at sine of x, y equals sine x, which is the top graph. It just basically tells us that when we have an angle of 0, so right in this area here, the sine is just the height of where this crosses the unit circle. So basically it's at 0 right here, and it grows and grows and grows all the way up until it gets to 1 at pi by 90, and then you can see it goes back down until it gets to pi, and then it keeps going down to negative 1 at 3 pi by 2, and then at 2 pi it goes back down to 0, and then it goes back up again, back down again, and it keeps going around. So it's periodic. It's going to keep going up and down like that. All right, so what we can see is if we take the sine of any one angle, then we could also add 2 pi, and it'll go right back to the same spot. The height will be the same, and so the sine of that angle plus 2 pi will be the same. Right, so you go around again, plus 4 pi this time, and it'll be the same again. So basically, anytime you have the sine of any angle, it's also equal to the sine of that same angle plus 2 pi, which is also equal, you could even say, if you subtract 2 pi, it will also be equal. And I mean, you could get ridiculous and you could write these forever. You can add 4 pi. You could add 6 pi. You could add 8 pi. All right, so this is actually another identity that we can use. Now the cosine x is just the distance to the right, and so same thing works for the cosine of x. If you go around by 2 pi, all the way around, it's going to be the same to the right. So no matter where you are, let's say we're right here, if I go around by 2 pi, it'll be the same distance to the right. So it doesn't matter. So we can say, again, the cosine of x is just equal to the cosine of x plus 2 pi. Or cosine of x equals the cosine of x minus 2 pi, or minus 5, or minus 4 pi, minus 6 pi. Any subtraction or addition of 2 pi or an even number of pi will be the same value. Now for tangent, it's a little bit different. For tangent, whatever angle you're at on the unit circle here, the tangent is the slope of that angle, right? But if you see here, the slope of this line and the slope of the line on the other side are actually the same slope. They're both going up. Or here, it's the same slope as down here. So if I take any angle, I only really have to rotate it by 180 degrees, and I'll get that same slope, right? 180 degrees, I get that same slope. So the tan has a period of only pi, not of 2 pi. So that one we can actually write tan of x equals the tan of x plus pi. Now you could also do 2 pi or 3 pi or 4 pi, any combination like that. Or even x minus pi, x minus 2 pi, x minus 3 pi. Now, I won't write it here, but of course that works for the reciprocal identities, like functions as well, sorry, the reciprocal trig functions. So cosecant theta, secant theta, and cotangent theta will have the same periods as sine theta, cos theta, and tangent theta, respectively. And so you can use that with the reciprocals as well. All right, another major thing to keep in mind is that the sine of any angle in the first quadrant has an equivalent one in the second quadrant. For example, if we have sine of pi by 4, well, that's going to be equal to sine of 3 pi by 4. If we have sine of like some really small angle here, well, there's going to be another one that's going to be the same height over here, right? So basically, any angle we have, you know, sine of any x is also going to be equal to sine of pi minus that x, right? So if we have, you know, like sine of, let's say this is the angle x right here, angle x, well then if you take pi minus x, you're going to get that same angle over here. So sine of x is always equal to sine of pi minus x. On the graph you can see it over here as well. Here's whatever you have sine of any angle here, if you do pi minus that angle, you're still going to be at the same thing. Now that's similar with cosine, except with cosine, it's the cosine is the distance to the right to where it hits the unit circle. So the cosine of an angle on this side in the first quadrant here will be the negative of the one over here, because on this side you're going to the left, so it'll be a negative, whereas on this one, on this side, you're going to the right by the same distance. Right? So if you have this angle, let's call it x again. If you have this angle x right here, and you have the opposite angle, the reflected angle, one which is pi minus x, the cosine on this way, and the cosine will be the negative of it. So cos of x is just going to equal to the negative of cos pi minus x. And the same sort of thing works for tan as well. If you have an angle here of, let's call it x, right? And you have the same angle but at pi minus x. As you'll see, the delta y, the height, will be the same height on both sides. The delta x will be the same distance, but this one will be positive on this side and negative on this side. And so if you take, you know, the angle x and the angle of pi minus x, they're both going to have a delta y over delta x, which is the same, except one will be negative of the other, right? So you're going to get a positive over a positive on this side, a positive over a negative on this side. And so the tan of x is just going to equal the negative tan of pi minus x. All right, what happens when we go the wrong way on the curve? Okay, let's say this is, if you're going, you do an angle of, let's say, pi by 3 is up here. Well, what if we did negative pi by 3? Well, what happens to sine? Well, if I go this way with sine, it goes positive, 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 negative, 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 negative. But if I go the wrong way, it goes negative, 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 positive, 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 positive. Right? It goes up to 1, down to 0. The other way, it goes down to negative 1, back up to 0. So the numbers are the same, like the values are the same, but opposite. So we can now say sine, of negative x is just going to be the same as sine x, except it's going to be the negative. But for cosine, if I go the correct way, it's positive because you're to the right of the y-axis, and then it goes to negative, negative, positive. But if I go the other way, it's positive, negative, negative, positive. It's the same. right? So if I go up by, let's say, 8/9, so 8/9 of pi by 2, so that would be 8/18 of pi, and I go this way 8/18 pi, well, it's going to be the same value. It's going to be the same distance to the right either way, right? So we could actually say that cos of negative x is just the same as cos of positive x. So if I do cos of negative pi by 4, it's going to equal the same thing as cos of positive pi by 4. If I do the cos of negative 3 pi by 4, it's to the left. It's going to be the same as the cos of positive 3 pi by 4. And you can see that in the graphs as well. So what happens for tan? All right, if I go up, if you look here, the slope is getting larger, 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 all the way up to infinity. If you go this way, it's going into the negatives, negative, 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 all the way to negative infinity. So this slope here is the negative of this slope here. So the delta y over delta x, y is going to be positive up here, but negative down here. But x will be positive on both sides, right? So basically, you have the same slope, except it's going to be negative when you go the wrong way, right? So it's going to be positive all the way up. It's going to hit infinity, and it's going to come back down, but now it's going to be negative. And then here, you're going to be, if you go the other way, you're going to be negative slope, hits infinity, or negative infinity, and then it has a positive slope right here. Okay, so we end up with the tan of negative x is the negative of tan x. All right, the last thing to consider is when I have an angle on the unit circle here, we've got, let's say we call this angle x right here. The sine of that x, which is the height here, will be the same as the cosine of a similar, right here, similar triangle over here, if this angle here is that same angle x. And as this angle, as I make this angle bigger, the sine gets larger. Okay, so make the x a little bit larger here. So now this x is larger. Well, I could do the same on the other side where I make this x larger. So as this guy goes up, the height gets larger, and this guy goes this way, the height gets larger. So we could actually say that the sine of any angle x is equal to the cosine of pi by 2 minus x. Right? If you're talking in degrees, the sine of 14 degrees is going to be the same as the cosine of 90 minus 14 degrees. So the cosine of 76 degrees. Try it out. Sine of 14 is a cosine of 76. Or you're in radians, say the sine of pi by 6 is equal to the cosine of pi by 2 minus pi by 6. And of course the same thing goes for the other way around, right? So if you're looking at this angle still, let's take some small angle. The distance to the right, which is the cosine, is going to be the same, if this is your x value, as the height, if this is that same x value, right? So we can also say the cosine of x is equal to the sine of pi by 2 minus x. All right, and if you look at the graphs, you can see like the sine curve here, starting at pi by 2 and heading backwards. So pi by 2 minus x, you start at the top right here, and it goes down all the way to the bottom and back up to the top. And the cos curve, this is the normal cos curve, starts at the top, goes down to the bottom, and back up to the top. So you can really see that the sine of pi by 2 minus x is equal to the cosine of x. Similarly, if you start at pi by 2 for the cosine curve, well, it starts at 0. And if you head backwards, it goes up to 1, back down to 0, down to -1, and back to 0. But the normal sine curve starts at 0, goes up to 1, down to 0, down to -1, and back up to 0. So it's the same thing. So the cosine of pi by 2 minus x, so heading that way, is the same as the normal sine of x curve. Now really we can go on forever about things that we notice just going through the unit circle and how everything's symmetrical. One last one we should talk about is the tan of x. So let's say we have an angle x here. The tan is just the height divided by the distance to the right, delta y over delta x. Well, if you have 90 degrees or pi by 2 minus x, if you notice, the cotangent would just be the opposite, would be the distance to the right divided by the height. Well, the distance to the right will be the same as the height of tan, and the height will be the same as the distance to the right of tan. Right? So the tangent of x will just be equal to the cotangent of pi by 2 minus x in the same way. Of course, on the graph, tan of x, you see it starts at 0, it goes up to infinity, and then it flips back to negative infinity, goes back to 0, goes back up to infinity. If you took cotangent, if you took that curve, checked it out, start at pi by 2, and it would start at 0. And if you head backwards, so minus x, you're taking away x, you'll see it'll get bigger, it'll go up to infinity. It'll flip down to negative infinity, go up to 0, back up to infinity. It'll do the same thing as tan x. So that makes sense that tan x should equal the cotangent of pi by 2 minus x. So there you have it. And those are all of the identities that you're going to really need to know. But we will give you we'll always have these identities available to you as you're going through the work for this chapter. And so it is really important that you understand where they all come from. But I would never ask you to write them out by memory or anything like that.